Hey folks, how's it going? Rosendo from MLH here. Just waiting for y'all to get through the ad block and ensuring that everyone is actually joining us. If you are seeing this live stream right now, hit me up in the comments. Let me know what's going on. Hope you found us well today and hope y'all enjoyed the opening presentation of Global Hack Week AIML. Really excited to have y'all. Yeah, let us know when you've joined us. Let us know when everything is good to go on your end. I see some hellos coming in the chat. I really, really, really appreciate it. Thank you so much. Uh, I'm not going to try to pronounce your name, but thank you so much for saying hi. Hello to you as well. I just don't want to butcher it. Yeah, we're really excited to have y'all. There is going to be some amazing content that's coming up right now. So we've got Mark Hornick from Oracle, who is going to be coming in and talking to us about Oracle's machine learning features and how they integrate directly into databases and some of the Oracle database features that you will be using throughout the week in order to tackle some of the Oracle challenges that we'll have presented to you for AIML week. A lot of really cool stuff that's happening. Yeah, exactly. So that's the brief about what's going to be happening in today's workshop. In addition to that, I just wanted to kind of like talk a little bit about the account redemption that was a big hot topic during the opening presentation. We were able to whitelist the accounts that were basically asked to opt in during the original check-in phase. But if you're doing it after opening ceremony, just to let y'all know, it's going to take maybe like another couple of hours for us to aggregate a lot of those emails. And after this workshop, you'll be able to go back, watch the recording, and then follow along with your fully updated Oracle database account with the $500 worth of credits. Hello from Texas. Hello from Florida. Hello from India. Love to see it. Love to see that y'all are joining us from so many different places. Yeah, I mean, really, like one thing I did want to sort of talk about here before I brought Mark onto the screen was how experienced y'all are with databases. If y'all have heard of Oracle before, let us know in the chat. Another thing I will let y'all know is that, like the workshop is going to be sort of broken down into segments. So if you do have questions, make sure you drop them in chat. We will be monitoring all of your comments coming in. And yeah, we'll let y'all know, like basically as soon as there's a break in some of the content, we will stop, take a look at the questions and answer the ones that we that we see and that are relevant to what we're currently talking about. If there are going to be answers to your questions later on in the workshop, we'll let you know as well. All right. Well, that being said, without any further ado, I did want to bring Mark up to the stage. So please give him a warm welcome. And yeah, um, give him the Global Hack Week energy that we've known to come and love. All right, yeah.
All right, great. Well, thanks for joining me to explore machine learning and AI capabilities in autonomous database. Rosendo, appreciate the introduction there with that. I want to show you a path from data to deployment, using your capabilities that are available in Oracle database. So if we can go to the slide deck at this point. This hacker's guide is going to focus on a few critical elements to help you get started in next week's hackathon. And as Rosenda said, I'm Mark Hornick with Oracle Machine Learning Product Management. I've been at Oracle for quite a number of years, started with development and leading development, and now in product management. So let's get right into it. The real fuel powering AI isn't just complex algorithms, it's also data. And the information that you scroll past, the reviews you click, the music you stream, it's all fuel for machine learning and AI. And we're going to explore using that data where it often lives, a database. Now, you can imagine having all this amazing information, but it's all over the place. It might be on your phone, your laptop, maybe your friend's laptop. Or if you're in a company or a university, different departments often maintain their own records, creating data silos. But this is where the databases come in. They can organize all your data in one place where it's easy to find, use, and make sense of. And in machine learning, it's all about learning from data. You feed your algorithm with a lot of it, like which movies each customer of a streaming service watched. This could be millions or billions of records. And the algorithm then finds useful patterns. But it's not just about having a lot of data. It's about having the right kind of data and knowing what to do with it. And that's the combination that can help solve real problems, from making better personalized recommendations to helping doctors diagnose disease faster. Now, we're talking about ML and AI projects using Oracle Autonomous Database, which makes it easier to create machine learning and AI-based applications. As you'll see, Autonomous Database is going to streamline the ML development process with integrated and automated tools. And this frees you to focus on what matters, thinking about the problem you're trying to solve and exploring the solution. Now, built-in tools for loading, exploring, and transforming your data help you to get data into shape, while pre-integrated machine learning features in the database let you train and deploy powerful models directly in the database. And on top of that, with integrated generative AI features that we have, it lets you interact with large language models also directly from your database. So it's easier and faster to develop AI applications. So what are we going to cover today? Well, I've broken this up into three main topics. We've got ideas, what do you want to do, otherwise called use cases. There's flow, what's the process or workflow I should use, and tools, what's available, and what can these tools do for you. And that's where we're going to have the majority of the demonstrations. We're going to show machine learning in action in the database, as well as the AI capabilities through the database. But let's kick off the discussion with some idea generation. Maybe you already have an idea of what you want to explore with machine learning and AI. But to start with, here are a few areas you might be thinking of. Engaging with users or customers, promoting videos or products, and dealing with equipment or engaging with students. And perhaps you want to improve the customer experience, like from streaming services or social media platforms, by creating targeted content and recommendations. You want these to be personalized to specific interests, maybe using a technique called customer segmentation. You might want to use machine learning to help understand what keeps followers engaged, or what content or viewers' traits can help predict this. Now, for products, what products or services should we recommend? Or, which products should be bundled for a new offering? On the equipment front, we often come across predictive maintenance. If service equipment, if we service it too soon, we're wasting money. But if we service it too late, it could mean expensive repair costs or even needing to replace it. There's also things like root cause analysis. And this can apply to many situations, not just equipment. But the idea is basically to find commonly co-occurring events or data points that include a particular outcome. Like if the temperature and pressure are high, the container bursts. That's pretty obvious, but there are a lot more subtle combinations that you might find as well. On the student front, maybe it's what students are likely to benefit from most of the features at a given university. Now, having the seed of an idea is a start, but we also need to decide which machine learning technique is likely to help. And let's go through a few of these to get you primed for that. We'll start with classification. It's a machine learning technique that we can use to predict, say, customers with high lifetime value, or which customers we should prioritize for marketing campaigns. Regression, we could also apply this to some of the classification cases, but we adapt that to predict a number. As instead of high, medium, or low lifetime value, we might want a specific dollar amount. And regression can also be used in forecasting. Of course, time series provides another class of algorithm that could be used for these same use cases, depending on how the data is set up. Now we turn our attention to clustering, where we don't have known outcomes. We don't know what the right answer is. And this helps with things like customer segmentation and document classification. Might even apply it to biology with grouping cell types, or just to find similar instances. Another technique, association rules, can help you identify cross-sell and upsell opportunities. It's also used for root cause analysis. And anomaly detection can help with transaction or claims fraud detection, or just identifying unusual cases. And these, of course, just scratch the surface. Now, having the right data is key to ML-based solutions, as you can imagine. Newcomers to ML often wonder, what does the data look like? We talk about this data, but it's often very abstract. So here's a quick summary of different types of data that you might want to become familiar with. When we look at data for supervised learning, things like classification and regression, it's required to have a known outcome that the algorithm learns from. So it can determine, did I get it right or did I get it wrong? Now, for classification, we want to predict a specific outcome, like, is this email spam or not? Or what's the sentiment of this email? The data looks something like this, where each user's attributes form one row in your data set. And you might have some demographic data like age, interest, education, and whether or not they take our offer, yes or no. And that's what we want to predict. Now, if we look at the regression side of things, it changes just a little bit. Let's say we want to predict a numeric outcome like house value using sales price. You can think about the app like Zillow. We have each sale of a house as one row in our data set, and we know the year it was built, square footage of the house, number of bedrooms, and of course, the sale price, the known outcome. Now, data like this can be fed to machine learning algorithms and AutoML, automated machine learning, to build machine learning models. And we're going to take a look at how to do just that. Now, if we look at unsupervised learning, where there's no known outcome, we don't know what the correct answer is. We're just using the algorithm to find specific types of patterns. For clustering, we might have some demographic or psychographic data about our followers. We can use this data to build a clustering model to find natural groups, or called clusters. Now, looking at what defines each cluster can help us develop targeted content specific for members of a given cluster. Looking at association rules, this technique is also known as market basket analysis for obvious reasons. What does the data look like here? Well, essentially, you have data where each transaction has a set of items. And you can relate this to an online shopping cart. Using this technique, you could identify rules like, well, if the user made an in-game purchase for items X and Y, then they're likely to purchase Z as well. And the last technique I'll touch on is forecasting. Using time series data, you typically have a timestamp column that orders the data and the column with the values, like the number of users viewing your video or sales of your merchandise. And this technique allows you to forecast several periods in the future. Now, when it comes to generative AI, we move from what we can do with the specific data we have to more creative efforts based on general knowledge of a large language model, or LLM. Maybe you want to create articles, stories, or even code, helping content creators, journalists, and developers. Or maybe give your users a better experience on shopping and content platforms by generating personalized recommendations. Education has a potentially big win by generating customized learning materials or quizzes for students. And this can take into account each student's individual strengths and weaknesses. And perhaps you want to assist with writing scripts for movies even, or help game developers with characters and storylines. Now, we talked about the data requirements for a few machine learning techniques, but what about on the generative AI front? Now, you've probably used ChatGPT or some other chatbots and provided your question or request to the LLM. If you had an ongoing conversation, you have your chat history there as well. Well, LLMs are subject to hallucinations and outdated information, right? They produce results that can simply be wrong. Although they're getting a lot better all the time at this, they still tend to make up things that they don't know, or also know only things up to a certain snapshot in time before them. Now, to improve on this, you might think about fine-tuning your LLM or trying to build one from scratch to work specifically with your data. But that comes with its own challenges. And this is where your database can help. You can augment your prompt with private data that's accurate and up to date. You can include documents, maybe like a user's guide or gaming usage terms, or specific customer or product information directly from a database table to help reduce hallucinations while using the latest information. Of course, you can use vector database functionality to help with some of this, but you can also benefit from augmenting your prompt with data queried directly from your database. I'll just throw out a term, retrieval augmented generation, or RAG, you might have heard of. It's a popular technique for enhancing LLM results. All right, so with that, we're going to move to the next section called Flow, where we're going to talk about machine learning methodology and process. But before I do that, let me just check back with Rosendo. Any questions that we need to cover at this point?
No, it looks like we're good to go, Mark.
All right.
Yeah, nothing specific to what was just mentioned. So
great. So let's move on to that. And at the high level, the machine learning process is pretty straightforward. You define your project, you get your data into a form that's useful for building a machine learning model, and then you use it. And that can mean generating predictions or looking at patterns found in the model. Now, finally, you deploy your solution in some application or environment where your users can take advantage of it. In practice, the flow is not so linear. Problems arise. Perhaps the data isn't as good as you thought, or the algorithm you chose isn't giving good predictions. But let's go into that in just a little bit more detail. As you can see, there are a few more twists and turns captured here. Fortunately, your autonomous database with machine learning has features to help you get through this process. We can start with, what are you trying to do? Define the project. What are your objectives and the success criteria, and how you'll know you have achieved your objectives. Then what's the data? As I mentioned, data is the foundation of an ML project. And so you might have a great project in mind, but you have data to support it. Where can you get that data from? And if you don't have your own, well, there are online sources like Kaggle, UCI ML repository, data.gov, and plenty of others. Then you need a convenient place to access and explore the data to understand how usable it is. And for us, that's Autonomous Database. Next, get the data ready. That we call this also data preparation. You need to clean that data to get rid of things that maybe you have a column that's called state names and has the value of Massachusetts, MA or Mass. Well, these will be treated separately by an ML algorithm. So we've got to clean that up and unify those. And we want to get consistent values from them. Now, we may also combine data from multiple sources and derive new variables. An example of this is where you have a timestamp when your user viewed your content or purchased an item. Perhaps you want to extract the time of day or day of week from this, and these become new columns or predictors in your data set. So now you're ready to build some models using ML algorithms to find patterns and make some predictions. This step is often called modeling. So it's a process in itself to select the right algorithm and the data, tune the models, and assess model quality. If you're not a data scientist, you could be tempted to use automated machine learning or AutoML to get significant help for certain types of problems like classification and regression. And I'm going to walk through how you can actually do that. Then comes the time of reckoning, right? Are your results any good? So you got to evaluate your objectives and success criteria. And if you decide to deploy your solution, to include it, say, in applications or dashboards, then you might even want to do what's called data and model monitoring to see, is my project continuing to live up to the results that I first achieved? And these highlighted steps are ones that are directly supported by Autonomous Database with simplified and automated features to help you get further faster. Let's look at the modeling step more closely, because we're going to be showing examples where we're talking about modeling. And so you should have an appreciation for what it means to cover all this. Now, we have multiple algorithms that you can choose from for a given technique. And the question is, of course, which should be tried and which will produce the best result. So we start with one algorithm, say SVM, and using our prepared data set, we build a model using the default settings, or what are called hyperparameters. And we tune those to hopefully build a model with better quality. And we're going to compare each new model against previous ones to select the best one. And then finally, we repeat this process with the next algorithm. Well, as you can see, this is really iterative and a trial and error approach that's expensive, both in terms of time and potentially even the compute resources. It also requires that you understand how to tune those hyperparameters for each type of algorithm, something that non-experts may not be familiar with. So at this point, let's look at the tools that you have available, because that's what we're really waiting for here. The first tools that I'm going to highlight is the database that supports everything that we're talking about, Oracle Autonomous Database. You can think of ADB as Oracle Database reimagined for the cloud. It automatically manages all the infrastructure, many DBA tasks, and data center operations as well. It also includes a lot of powerful analytics like machine learning, spatial and graph, JSON, blockchain, and others. Now, when we talk about the tools that you have available in the database that you can start using for next week's hackathon, maybe you're a SQL or PL SQL user. You can start with the SQL API that allows you to build machine learning models and score data directly in the database using SQL queries. And you'll see how we do that. Maybe you'd like to use Python or R. Here you can leverage the database as a high-performance compute engine from these languages. So whether for data exploration or preparation, in-database modeling, or invoking your Python or R code. With Python, you also have an API that supports AutoML. Now, you can use third-party IDEs for SQL, Python, and R to interact with your database and develop solutions, but you also have access to a built-in notebook environment that includes SQL, Python, and R interpreters. Notebooks support versioning, collaboration with your teammates, and job scheduling to run notebooks on a recurring schedule. Now, I mentioned AutoML from the Python API, but there's also a no-code user interface that does the modeling step for you. You just specify the data table and the column of data you want to predict, and the user interface does the rest. You can even generate a notebook that uses the Python API so you can see the hyperparameters that AutoML came up with. This provides you with a starter notebook that you can then evolve to do more with. You can also deploy in database models as well as third-party machine learning models, maybe based on TensorFlow or other native R Python libraries. And this can be done through a component we have for OML services that is based on REST APIs. Now, you might also want to monitor your data and the accuracy of your machine learning models. And you have access to no-code user interfaces that support these. Now, such tools help meet your MLOps objectives for solution deployment. And with Select AI, there's the ability to use LLMs directly from your autonomous database. So let's switch to the demo. We're going to look at OML notebooks to build models using some of these algorithms from SQL, Python, and R, as well as the OML for Pi AutoML to predict if customers will purchase an item. And then we'll look at a few other features as well. So I'm going to stop sharing at this point and reshare my system. Present. All right. So what we're looking at here is the Oracle Machine Learning User Interface on Autonomous Database. And from this UI, you see we have a number of different quick actions, tools that we can get to. The AutoML user interface, models, data and model monitors, notebooks, jobs, and a set of examples that you can use for understanding how do we use some of this technology. Well, the first thing that I want to do is go into notebooks. And we're going to look at some code at this point and show you how we can build some models. So I'm going to open a notebook called OML Modeling using SQL, Python, and R. Now, what we have here is an environment that allows me to do versioning of a notebook if I want to make changes and I want to make sure I don't lose anything from making subsequent changes. I can export and import notebooks as well. With Autonomous Database, you have different settings for how fast you want it to go, how much parallelism you want it to use, whether it's low, medium, or high. It's a very simple way to increase the resources for that. Now, we're in the notebook, and so the first thing we're going to do, I'm just going to get this started so we have the environment ready for us when we want to start running some code. But you'll notice that we're running a SQL query here. And this query is going to allow us to create a view from data we have in our customers table and also some demographics. So we're looking at things like, has the person purchased the product? What's their age, their income, their status, etc. So we're doing a simple join on this one. And we can obviously run that in the notebook environment. Once we have that, we've got our table. We're actually going to materialize that as well. We're going to create it as an actual table in the database. And we can see some of the results coming back from that. We've got our customer ID, a unique identifier for the customer, whether or not the customer purchased the item, and other fields as well. And these are all going to be predictors that we work with. Now, another thing that we typically do in machine learning is to split the data set that we're working on. Put some in a training set, what we're going to build the model on, and some others that we're going to test the model on as well. And so here we're doing a 60-40 split, and there are capabilities directly in the database that allow you to do that. So now comes the time to build the model. And one of the algorithms we have in the database is called random forest and allows us to predict whether or not the person has purchased the item. Now we're looking at a PL SQL script. There's a package in the database called DBMS data mining and the function create model 2. We're going to create a model in the database itself, purchase product model. And then we have the algorithm name, random forest, that it's a classification problem because it's a yes or no response. We're specifying the data that we want to work with and the target name that we're trying to predict, in this case, purchased. And we run that, and it comes back very quickly on this data set to say, okay, we've got our model. Now, we can view one of the features that comes out of a random forest model is a ranking of which features are the most important for making predictions. And so in this case, we're going to get back the attribute name. We see years residence has the most value for this data, age followed by occupation, household size, and others. Now, how do we actually deploy information from this model? How can we use it to make predictions? Well, one of the things that we do in Autonomous Database is have integrated prediction operators. So these are built right into the SQL language. And if you're familiar with SQL, I think you can appreciate that it would be very easy to incorporate this into an application or dashboard simply by invoking SQL, whether you use JDBC or ODBC or some other interface that allows you to interact with SQL. We mentioned the model name. This is a first-class database object, purchase product model. And then here are all the values that we wanted to consider when making that prediction. And this comes back very quickly with a prediction. In this case, this customer is not necessarily interested in the offer that we have. Now, you can do this in batch as well. Suppose if you've got 1 million customers that you want to score. Well, we can do this by simply saying, let's get the prediction and the prediction probability off of our customer data set. And if we wanted to make this a static table, we could materialize it, just prefacing this with create table as select. And that will put all of this data in the database. Now, I can also incorporate this with queries. So do I want to have only those customers that are likely to accept the offer with a probability greater than 80%? We can wrap this into a single SQL statement. And because it's not good enough to just say, well, we want to know yes or no, is this customer going to buy? We might also want to know why are they going to buy? What are the features that are most predictive for this particular outcome? And in this case, the first customer who is predicted not to purchase, age is the most important thing, followed by years residence. Whereas in this other case, it's the opposite. We have years residence of a certain value and age as well, and they're likely to purchase this. Okay, so that's SQL. And because we're a database company, of course, we have a SQL interface to this. But OML for Pi allows us a Python API to do the same thing. So we're going to build a random forest model, just like we did before, but we're going to use the in-database algorithms through a Python API. Well, one of the first things that we do is we have a proxy object that we want to get to our customers table. So we're going to create what we call a data frame proxy object to the customers table. And this is going to allow us to manipulate that table as though it were a pandas data frame. So you see we're invoking some standard Python syntax to split the data into 60-40 for the train and test data sets that we'll want to use. Here we're going to separate the predictors from the target that we want to predict purchase. And finally, then we have an object, RF, that is going to represent our in-database model. And then we fit that model with the data, customer train, X and Y, that are unique identifier, and the name of the model that we actually want to give it, in this case, purchase product. Now, once we build this in the environment, we can then use it for dynamically scoring with the prediction operators. So we're going to do something very similar with our test data. We get predictions here, prediction probability, and the merge. So when we start a new interpreter for a different language like R or Python, we're actually needing to have that environment be initialized and that engine started. And after that, then the result comes back very quickly. So in this case, we have the model that's just been built. We see the settings that the database determined that should be used for it, as well as some other values, including the importance ranking of all the attributes. So this is just coming straight out of Python. When we run this to dynamically score our customers, we see that we get similar results to what we had before. And then let's go on to R. So if you're, I wonder if there are any R users on the call here that might be interested in taking advantage of creating proxy objects to database tables directly from R. We have an ORI sync that is going to give us that proxy object, then going to set up sampling so we can create our train and test sets, and then build the random forest model. And you'll notice that we're using the R formula specification that says purchase is what we want to predict against all of the other predictors, and this is our train data. And when we produce that result, here's the resulting model with the settings that were selected and the attribute importance for that. And of course, we can dynamically score here as well. What I'd like to do, though, is let's move on to the automated machine learning, with AutoML for Pi. Now, as I said, what we want to take care of the process of finding which algorithm is going to be the right one, which data should actually be used, and how do we tune these hyperparameters. So with automated machine learning, we can start off with algorithm selection. And we're going to say we have a classification problem, and this is our data that we're using, just like we did above, but we're not going to select the algorithm itself. We're going to let AutoML tell us which algorithm is likely to be best. So when we run this, we see that support vector machine with what's called a Gaussian kernel is actually predicted to do the best, followed by random forest and other algorithms as well. Now, the next step is feature selection. So feature selection means that what are the columns of data that I should really be using to build this model? Can we reduce those columns to ones that are most meaningful? And in this case, we're going to see that instead of having 10 predictors, this was reduced to 7. Now, you can imagine if you have hundreds of variables that you're using, columns of data, that some of them might not be useful, and fewer columns means less processing and even producing faster results. Now, the next thing is model tuning. So we have the algorithm that we want to use, SVM Gaussian. We have the data that we want to use, the reduced training set. And now we're going to tune that model. And just by running this code, we'll get back the specific settings that were used by AutoML, as well as some other values. And so that's basically taking care of what we have for AutoML with the Python API. But let's go one step further. In the case of automating this whole process, we have an even simpler way, because not everybody wants to write code, whether it's SQL, Python, or R. So we have things called experiments. And you can create an experiment fairly easily because we might say that we want to deal with, let's just see, what are we going to include in this? We could do Brooklyn home sales, credit scoring, customer purchase. Let's go with customer purchase. So we'll create a new experiment, customer purchase. And then we have our data source. And this is going to be the customers table. Just like we used before, the data set has to be prepared for this according to the criteria that we set out earlier. The column that we want to predict is called purchased. We have a unique identifier, the customer ID, and the system knows that it's a classification problem because there are only 2 outcomes, purchased, yes or no. Now, we could stop here and we could start our experiment, but there are a couple of other things you might want to change, like the number of top models. Maybe we don't want 5, we want 3, or we want more. The database service level. Well, let's use the highest one so we get the most parallelism from the database. Now, if you're a data scientist, you may have a favorite model metric that you want to use for determining what is the best model in this case. But we're going to stick with balanced accuracy. And you could even refine the set of algorithms that are going to be tried. You can imagine if you did this manually, would you want to go through all of these individual algorithms? And do you know all of their specific hyperparameters? Chances are not. Even the experts sometimes struggle with that. So here we've got the features that we're going to use. We see our target purchased. Cust ID is not included in that. And now we can start our experiment. So we're going to say faster results. Now, as this is starting, it can comment on a couple of things. Faster results means that we're going to try fewer what are called pipeline combinations, and that is different settings that will be applied to the different sets of data to produce the resulting model. Whereas better accuracy is going to try more of those combinations. The important thing to note is it's not doing a grid search. It's not doing an exhaustive search. It's actually using a gradient descent algorithm to zero in on the most appropriate settings that can work. So it's a much more optimized solution. Now, this experiment is running. It's doing algorithm selection, adaptive sampling, feature selection, and we see that it already came up with 3 candidate algorithms. We've got naive Bayes, neural network, and support vector machine. Now, this is just going to take a minute or two, but rather than wait for it, let's go back and look at the experiment that's already completed. So here is our leaderboard of models that were produced. We have support vector machine linear being first for that. And we can click on that model to get a little bit more information about it. Like, which are the features that had the most impact on predictions for this specific model? And we see household size, occupation, and education are there. Then we have the confusion matrix, and that tells us how well did this model perform? What did it get right? And what did it get wrong? And what types of errors did it actually make? Now, the next thing we might want to do is to rename this model. And we have names that are randomly generated, but here we've already renamed this one to customer purchase. Something else we can do is to create a notebook from this. And so let's say that we create a notebook from this first one. We'll just say OK to that. And this is generating Python code using the AutoML for Pi API that can serve as a starter notebook for you to work with. Just going to run this whole thing. It'll take a few seconds to get the environment together. But notice what it's doing. It created a select statement here for the columns that were actually used by AutoML. And it lets us get a proxy object, here OML sync, using that query. So now we have a handle, a proxy object to the database content that we want to work with. And then we're preparing the training data itself. In this case, we're separating out the whether or not it was the predictors and then the purchase column for that, and the resulting settings. So in this case, we see all the different settings that AutoML came up with. And what we might want to do is simply accept these, because this is what AutoML did. But then we'll go ahead and perhaps tweak them, add additional settings, and see if we can do better than AutoML did as well. It builds the model for us, and we see the resulting model that came out of that. Now, this model, or I should say this notebook, can be scheduled to run on regular intervals for that. So let's just take a quick look at job scheduling as well. In this case, we could go into create a job and give it a name, select one of the notebooks that we have in our environment, and then say when do we want it to start and what's the repeat frequency from it. And there are some other advanced settings as well that one can specify for that. But that allows you to essentially set up a recurring schedule for a job and know that it's running to perhaps rebuild your model every night or once a week or once a month, however you'd like to work that. Okay. Let's go back to our experiment, because there's only one other thing I would like to highlight for you in that. And that is we can also deploy a model to OML services to serve as a REST endpoint. So in this case, perhaps we have a cust, we'll call it 3 or cust 2. We've got a version 1.0 and a namespace, perhaps demo. Thinks I already created one of those. Let's make this 23. and we have the demo, and then that we want to share this with others. So we're going to say OK. And this deployed the model without writing any code to OML services. And then we can look at that model in our models listing here. So let's go to our deployments, and we had called this cust, and there we see cust 23 in this case. We can look at the metadata for that particular model. What are the predictors and the target? And also, this is the Open API specification that says we can use this as a REST endpoint immediately for including with applications and dashboards. And with OML services, it provides the environment for you. And this is perhaps something that you really want to consider, because normally when you deploy machine learning models, you've got to create a VM. You've got to configure a container that has the Python R engine, and then you have to have the model in that. And there's a lot of overhead for that. This is an environment that is provided by Autonomous Database. So once you've deployed it, you can just immediately start using it. You don't have to do any further steps, and you're only charged for the actual compute, which is typically minimal for leveraging that. Now, one other thing that I'd like to touch on is just, there are monitoring interfaces for data and models. There are templates that many examples that we have in the database as well. So in this case, maybe you want to find what are we doing for a decision tree algorithm. And we have notebooks for Python, R, and SQL that will show you how to work with decision trees. SVM, or everything that's going on with clustering. So this will give you a very easy way to get some examples and notebooks that you can actually run. If you simply click on the tile, you can do create notebook. If you click on the name itself, it will open it so you can see it, but you won't be able to run it from that. Okay. So I think that covers most of what I wanted to get to here. Let's go back to the slides. So I'm going to stop sharing, and we're going to represent. Okay. All right. So, we highlighted, a few of the algorithms and techniques in the demo. But OML offers a lot of techniques to support different use cases. And you might be wondering why we have multiple algorithms for a given technique. Well, some are better at finding patterns in data than others. Some algorithms give you a better understanding of the patterns or insights that were discovered, and some are faster than others. And there's a lot more to be said about them, but there are a couple of links here that you might find useful, and those be shared in the slides. You can also use Python and R, third-party packages from the respective ecosystems, and augment that in Autonomous Database. So if you want to have your favorite package and you'd like to incorporate that into the notebook environment, there are ways of doing that as well. But I'd like to move on now to Select AI, which allows you to build applications with large language models. So what is Select AI? Well, Select AI is the name of a new component that gives you easy access to LLMs from Autonomous Database. Now, you can query your data using natural language, which can help you write SQL queries or enable your users to explore their data through a chatbot, all without writing a line of SQL. Now, perhaps you want to chat directly with the LLM to generate code. Maybe draft an email or explain a query. Well, you can choose from a range of AI providers and easily switch between LLMs as well. And because it's available from SQL and PL/SQL, you can easily use Select AI with tools like Oracle Apex, a no-code user interface, or low-code user interface for developing applications, your favorite SQL IDEs, and of course, database applications. Now, on the SQL generation front, just to set the stage, you may know that you could ask ChatGPT to generate the SQL to find our top 10 streamed movies. Well, if we present this to ChatGPT, we get back a pretty reasonable looking query, as you see here. You see that it joins tables that it invented to the movies and stream data, and and this is okay, but this is really a form of hallucination, right? Because we didn't tell it that we have such tables, let alone their columns. And while the query looks good, if you tried to run this against your database, chances are it's not going to work because it doesn't conform to the tables in your specific database. And so that's what Select AI does, is to have a SQL query generation pipeline where the natural language prompt that you provide is augmented with database schema metadata. The user prompt, which might include things like, what are our top 10 streamed movies, or find the top 3 baby boomer big spenders. Looking at the second prompt, it really highlights the value of the general knowledge of the LLM. What's a baby boomer and what's a big spender? The LLM can resolve these types of things rather well. And then we have the database schema, the metadata. And this includes the table names, the column names, and their data types. And we even pull in comments on tables and columns because you might have added some more information that would be beneficial to the LLM. And that gives us an augmented prompt, which we can then submit to the LLM to generate our SQL query. Now, Select AI automates this process for you, of course. And you can choose an AI provider like OpenAI, Azure OpenAI Service, or Cohere. And you need to have an account that gives you API access to those services. That's not a part of the Select AI capability. And then finally, we can run that query. Now, to enable this natural language to SQL generation and LLM interaction, Autonomous Database provides the PL SQL package, DBMS Cloud AI. And you can use a standard select statement with the keyword AI and your prompt, as you see here. There are several actions that you can take as well. You can say run SQL, and that returns the SQL result that you can manipulate as any other row set. And that's the default behavior, so you don't have to actually specify that. There's show SQL, which returns the generated query. There's a narrate option that returns a conversational format that actually sends your result to the LLM to say, put this in text. That is a nice way to read it as opposed to seeing it in a tabular format. And then chat is a general AI chat to get you the results that you might have gotten directly from the LLM and not using the database content at all. Now, we talked about developing applications using chat interaction with an LLM. And here's a scenario where we could combine machine learning and Gen AI. We'll use machine learning to produce the churn model that predicts which customers are likely to cancel their subscription to maybe a movie streaming service, and then reach out to those predicted churners with LLM-generated email. And that email can contain offers or specific movie recommendations that the LLM came up with. Now, to do this, we get context from our autonomous database instance, perhaps by querying data that we have on our customers. And this helps the LLM recommend movies that this user might like and generate a compelling, personalized promotion to keep them from canceling their subscription. Now, through prompt engineering, a topic that you're going to be hearing about later in another session, we'll need to give specific instructions to the LLM along with customer-specific data to get back a targeted response. But I want to show you another example involving enticing a user to visit a place that they've expressed interest in. Now, if we were to start developing an application, we might want to have a table of tasks and a description of the rules we want the LLM to follow. And this could be for many users or many individuals that we want to reach out to. We might include specific customer demographic information that could be useful to the LLM in constructing a response. In this example, the task is to pick 5 great things to do at a location of interest, where the location is one of the columns in our table. And we have our customer, Janine, and that she's interested in Paris, and we know what her age is, and that she's not a dog owner. But let's put this in a form that's more useful to an LLM. Using the built-in JSON functionality in Autonomous Database, we can easily convert this to a JSON document. And you see in the select statement that we're using the JSON object. So this is a built-in feature of Autonomous Database. And here's how you can chat with the LLM using the generate function that's part of the DBMS Cloud AI package. We've inserted the prompt that asks to generate an email using the information from our JSON string we just produced. And the AI profile that specifies the LLM is here, and the chat action that we want to take on this. All right. So with that, I'm going to switch to a brief demonstration of Select AI, first through OML Notebook, so you can see how we can do that through code. And then I'll show you a custom chatbot that's built using Oracle Apex. So I'm going to stop sharing here and switch back. Okay. Great. Okay, so we're back at the Oracle Machine Learning user interface on Autonomous Database, and we're going to go back to our notebooks listing, and we're going to click Select AI to open up that notebook. Now, effectively, what we have are paragraphs. I'll just get this running, that take us through the process of how do we enable Select AI. So I'm just going to show you a couple of the admin steps that you'll go through to do this. And these are detailed in blog posts that I can point you to as well. But an admin user is going to add you to an access control list. And this is just code that you would run as an admin in your database. You also have to grant access to the DBMS Cloud AI package for your user schema. In this case, our user is OML user. Then you're going to create an OpenAI credential if you're using OpenAI, or you might use the Cohere interface, or you might also choose the Azure OpenAI service. And even recently, we've announced support for the OCI generative AI service. In this case, we create a credential, give it a name. This is going to be OpenAI, and the password, which of course I'm not showing here, is a token, perhaps, or that you get from the AI provider that you would include in here. And now that enables you to take advantage of that provider's service. As a user, you're going to create what's called an AI profile. And the profile says, I want to use OpenAI in this case. We know who the provider is. We have the credential. The key thing, though, is what tables do we want to have considered for this? In most cases, some of what your projects will be will probably just have a couple of customer tables that are available in your schema. But in larger schemas, you might have hundreds or thousands of tables. And so we want to zero in on those that we want the LLM to actually consider. So here we're looking at customers, sales, products, and countries. Finally, we set the profile. And this allows us to start using this in a SQL script. So the example that I showed earlier, we're going to use the generate function from DBMS Cloud AI, and we're specifying a prompt, generate an email according to the following JSON specification. And this is everything that we generated from that previous query that I showed a moment ago. Profile name is OpenAI, that we want to do chat. We're going to run this. Now, it's going to take a few seconds because it's going to contact the LLM, and it's got to think about, okay, I need to generate the email for this. So this will come back in a couple of seconds. And it did a pretty good job. Discover 5 amazing things to do in Paris. And it's referring to Dear Janine, and of course, interest in the Eiffel Tower, the Champs-Élysées, Le Louvre, and other sites as well. So that's pretty good. But what if we wanted to do something that's more specific to SQL generation? Well, in this case, if I don't know how to write SQL queries, I can just say, select AI, how many customers do I have? And it comes back with the answer. What's the query for that? I can say show SQL, and if I didn't know how to write such a query, I can say get that immediately and incorporate that into my application. So it helps you to understand how to write SQL as well from natural language. As a developer, that can be really powerful. Here, what are the unique product names? So it can actually put in unique constraints for that so that you get the proper result. I had earlier the find the top 3 baby boomer big spenders. Well, here's the query that comes back from that, showing that it understands that the birth year between 46 and 64 constitutes baby boomers. And it's also ordering by the amount sold. So it's prioritizing those that are considered big spenders. We might also want to use chat to learn about a certain topic, like autonomous database. And so this will come back and tell us autonomous database is a cloud-based database service provided by Oracle, and goes on from there. But suppose if you wanted to have it as a further developer aid, that I don't know how to create a table, or I don't want to have to type out the table specification. So maybe you want to create a table that's for agents, and you have an agent name, age, and address, and you just run that, and it's going to generate that content for you that you can then just use in your application. Generate Python to display a confusion matrix. If you didn't know how to do that, well, here's a way to get the LLM to do that for you directly in your notebook to help you get further in your coding. And even if you did know how to code this, if you didn't want to, it's a great productivity aid. And of course, we can run that code as well. All right. So the next thing I'd like to highlight, though, for you is that we can actually have applications that hide all of this complexity, right? We don't want to even have to write any SQL for this. So this is an Apex application that was developed, and it allows us to interact with the LLM through a natural interface. And we can even, this application allows voice. So let's even see if that's going to work for us. So I'm going to find the top 10 rated customers that are predicted to churn. All right, so it captured the for us, but it did get the rest of it. So let's see what comes back here. And notice that we're not asking our database in this case. And what that means is that it's actually going to not be able to answer this question for us because it doesn't have that information. This is interesting. This is taking a lot longer than expected. Okay, it doesn't have access to the information. That's what we expected. It even tells us what we could do there. But let's go a little bit further and say, let's ask our database. Find the top 10 rated customers that are predicted to churn. And since it caught that, I'm going to take that out of there. And if we run this again, it's now doing that prompt augmentation, leveraging the metadata from the database table. And by using Select AI, it's going to the database itself to run that query and produce the results back for us. And that's very straightforward to get a table now. That shows us these are the customers who are likely to churn. We had given them a rating from a previous exercise, and this is their churn probability. We'll just do one other thing. Let me get this here. Generate a friendly email to customer Gilbert Lee with 2 action thriller movie recommendations available through our movie stream service. That worked better. And we're going to run this. And again, this is going to go off to the LLM. We've provided it some information. We want it to craft an email for us. So you could imagine a whole bunch of different ways of leveraging this technology to solve really cool problems for the hackathon even. We'll just let that finish its execution. The LLM is really thinking hard about this one. The question is, which movies is it actually going to recommend for us? There we go. So, dear Gilbert Lee, I hope this email finds you well. And it's recommending Inception and Mad Max. and best regards. So it did what we expected it to do. All right, so that's it for that demonstration. Let's just wrap up here. I'm going to switch back to the slides. Okay. Okay. So, these blogs here and the Live Lab will give you a good step-by-step for getting started with Select AI. You can find these at the links shown here. You can just go to blogs.oracle.com/machine learning, and I believe that they're being put in the chat as well. There's a Live Lab. Oracle Live Labs are environments where you spin up an autonomous database instance, and it takes you through all of the different steps you need to solve a certain problem and get familiar with the technology. And this one is, chat with your data in autonomous database using generative AI, and it's a great introduction to this feature. So if you're interested, I highly recommend it. Now, so that brings us to the close of our session. We've explored a range of ideas, process flows, tools, and how to get started. So whether you are a SQL, a Python, or R, ML engineer or developer, or whether you like to use REST or prefer no-code user interfaces, you can start exploring autonomous database to build your AI and ML-enabled solutions. So good luck next week, and be creative. Here are a few suggestions, a few additional resources. I think they might also be being put up in the comments, and you can find those for your moving your journey forward. And thanks for attending.
Awesome. Thanks so much, Mark. Do you have any time for some questions that came in through the chat earlier, or?
Yeah, sure. Happy to.
All right, wonderful. Okay. So first question comes from Tintin, 1992. Is there going to be a Java runtime environment version of this workshop, basically? So someone that uses Java, I think this user was also asking about other Java related things earlier. So
yeah, I mean, Java, there certainly you could wrap, say, the Select AI capability in a JDBC call to invoke that. You can also invoke other SQL and PL SQL calls through that. But as far as having a specific Java environment, that's not something that we've enabled in OML notebooks. So you would have to have a separate client to allow you to work with that. But it is something that's worth considering for the future.
Gotcha. Here's one from Techie Wizard. What separates machine learning from AI?
That is really a great question. So if you think about it, you could have the big picture of AI is including perhaps everything. Machine learning is allowing us to work with data sets that and specific algorithms that produce specific results. So with machine learning, we actually have different algorithms, as I showed earlier, that produce like classification results or regression. And they're not general purpose. They are targeted at a specific data set for a specific type of result. Whereas in the case of generative AI, that has general knowledge, and we build these models on tremendous volumes of data from the internet, all documents that you can possibly get your hands on, and it learns that information from it, and then it leverages aspects of machine learning even to enable it to do those results. There are a number of papers and videos on how do we think about generative AI and what goes on behind the scenes? But I think that's really one of the key differences as to machine learning in the traditional case is allowing us to solve very specific problems with purpose-built models. In the case of generative AI, we're using a general purpose model to allow us to solve a much broader set of problems.
Awesome. We've actually got a follow-up question from Shellshock. Is machine learning for efficiency and AI for predicting and presenting?
Oh, okay. So when you talk about efficiency, if you have specific data that you want to target for a particular solution, yes, that can be very efficient and effective because it's leveraging the exact data that it should be working with to produce the outcome. And if you're doing classification and regression, you also have known outcomes that you're trying to test it against. In the case of AI, you're using a general purpose language or model for that, and you can do a lot of creative. Get a lot of creative results, whether it's trying to generate content for emails or reports or documents or stories or images and those sorts. So that's where it's also very beneficial. But because it has general knowledge, as you saw in one of the generative sessions I just ran, we can ask it to make movie recommendations because it has general knowledge about movies and actors and all sorts of other information. And you can draw upon that to help make predictions as well. So it really depends on where you're going. If you had data that was specific to your customers and their interests, say in certain movies, that might be a better bet for you. But if you don't have that information, then the generative AI model is going to give you a lot more latitude in what types of recommendations you can get.
Awesome. Hope that answers your question, Shell Shock. And we have another one from Severe Six. What is the difference between using Oracle and using Postgres SQL?
Well, perhaps that is a big question. The difference between one of the key things for Oracle is recognized as a extremely secure, powerful, enterprise-ready environment. And so there's a lot of content that we have in our websites and elsewhere that can perhaps break that down more specifically. I don't want to comment on other vendors at this point. Simply to say that this is what Oracle provides, and there are a lot of resources out there that can perhaps compare and contrast those for you.
Awesome. We have just another comment. Just someone wanting to tell you it was a great session.
Thank
And
you.
another question just asking if it's appropriate to reach out to you via LinkedIn to bounce some ideas off of you regarding an idea they have for the nonprofit space.
Sure, that'd be great. I'd love to connect with you.
Awesome. All right. And honestly, with everything else, I know there are some other questions here about how to get started with autonomous database, how to, get free services using Oracle machine learning and things of that nature. If you have any other questions with regards to how to get started with your account, I'll be able to answer those via Discord. Join us on the Discord channel at hashtag ask-oracle. We'll be there and, answering all of your questions and getting to your queries in a timely fashion. And if you've already signed up for an account and checked in after opening presentation, we will have your accounts whitelisted after this session, and I will be making an announcement via Discord to let y'all know. With that being said, really, thanks again, Mark. Really appreciate your time here and for going above and beyond answering those questions and putting together a great presentation. And thanks for everyone else that joined us. We really appreciate your time here and hope y'all learned something great.
My pleasure. Thanks for having me. Take care.
Bye, y'all.